What?
So trigonometry. They didn't hear that.
So trigonometry.
There we go.
Trigonometry, really simple. If you take the first part, guys. Okay, so the first part of the word is basically referring to a triangle. Okay. So it's, and the last part is for measure.
What is there binomial?
Okay, so we're basically looking, we're looking at angle measures within triangles. Okay, and the three, so there are 6 trigonometric ratios. That's what they are.
Can you say that 5 times
Trigonometric. So, yeah, so it would be nice if you guys could be quiet now. So a ratio is something that we learned in chapter 7. It's just a comparison of 2 numbers. It's a fraction. Okay, so when we think of this, we think of the fraction. And the 3 most common trig ratios, so we'll say trig in abbreviated form, so we don't have to always say trigonometric, just trig. The trig ratios. So our trig ratios are sine, cosine, and tangent. And you will see they're abbreviated by the first 3 letters in their name. So you'll see on your calculator, it'll be sine, but it'll just say S-I-N. Cosine would just be C-O-S, and tangent is just
Yeah, that's what they were doing. But Yvonne was trying to get sign and stuff, and
Okay.
I have no idea what you're talking about.
What does it mean? I have questions. What do you want to say? Like exponent, negative.
Okay, so that's a topic for another day. That's for later, just a minute. Okay. So the way that the trig ratios work is that we have to look at one angle at a time. So when we look at these angles in terms of geometry, we're just going to look at the acute angles. So we're not going to do sine, cosine, and tangent of 90 degrees. Okay, we're looking at angles A and angles B. Angle A and angle B. So when we refer to the sine of A, so here's sine of A, it's going to be, let me just show you here. So here's A. If we look directly opposite, we see side A. And here's the hypotenuse. And then we have what's called the adjacent side, adjacent to that angle. Okay, so sine is defined as the side opposite over the hypotenuse. Remember, I just told you that they are ratios, so it's just a comparison. So it's A over C. For the cosine, it's going to be the leg adjacent to angle A, which is B, over the hypotenuse, which is C. And then the last one, the tangent is going to be the leg opposite over the leg adjacent to that angle. Now, okay, so here's basically, the idea is, what if I change this to the sine of B? So just as an example, so the ratio changes depending on which angle I'm looking at. So sine is defined as opposite over hypotenuse. So if I look at B, the side opposite would now be little b. Right. So this is where we have to be really careful. So whenever we're working with the trigonometry and later on when we solve right triangles, whenever I use capital letters, the capital letters are going to denote the angles and the lowercase letters match with the opposite and they're lowercase letters. That's all. Now, SOHCAHTOA, not a real word, but it's a word that will it doesn't, but I will show you. Sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse.
Renee doesn't why.
Tangent
This is so much more confusing.
is opposite over adjacent. So often what we'll, like,
Henry, so.
guys, can you please stop talking?
So control.
Stop interrupting. For some of you, it's going to be easier for you to just remember that sine is opposite over hypotenuse. Some of you, you'll just know the definition. This word, sometimes students will just write it at the top of their quiz or test, just as a reminder, so that you can remember which, like sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and then tangent is adjacent, or sorry, opposite over adjacent. So just think of it as separated into those three parts. Because the order is important. Just remember, it's kind of like you read sine is the opposite is over the hypotenuse. So whichever one comes first, that's the one that goes in the top. Adjacent is over the hypotenuse, and opposite is over the adjacent. Okay, so we are going to look on the next page. We want to find the sine of r, cosine of r, sine of s, cosine of s, tangent. Okay, so again, looking at the triangle is going to determine, and the angle that we're provided is going to determine which one's opposite, adjacent, hypotenuse. So let's look at r first. R is right here. So sometimes I'll just circle the angle so I know that's the one I'm looking at. Although be careful because I'm gonna end up erasing, and then I'm gonna look at s because it's gonna change. So for r, if I'm looking at r, which one is opposite, which one is adjacent, and which one is hypotenuse? So the hypotenuse is the easier one, right? So, Shira?
4 is opposite, 5 is
Good. Right, so remember, so we have this SOHCAHTOA. Trust me, well, you'll see it enough that you're not going to forget how to spell it. Okay, so sine of r, so we're going to have opposite over hypotenuse. So sine of r is just going to be 4 over 5. Okay, just write 4 over 5. So in this case, we're going to express each ratio as a fraction, so we've done that. And then as a decimal rounded to 4 places. So if you have your calculators, this actually, we don't have to round to 4 decimal places. It just is exact. 4 divided by 5.
So we can't leave it as a fraction.
I want you to write it both ways. Wait, 4 divided by 5?
I got 0.7.
4 divided by
Okay.
5 is 0.8.
All right, hold on. We're not pressing the sign button. We're just doing 4 divided by 5.
That's 0.8.
Okay, next one, cosine of r. So cosine of r, that's going to be adjacent over hypotenuse. So that's going to be 0.6.
Starting to doubt yourself there a little bit.
And
Like a little bit confused.
and tangent of r is opposite over adjacent. So that's 4 over 3. Now this is the only one that doesn't. This is 1.3 repeating. But we want to make sure whenever we're working with trig ratios, we're going to have very small numbers. And okay. So 4 decimal places is always what we want to round to when we're working with the trig ratios, because they're always going to be real small numbers. For sine and cosine, they're actually always going to be less than or equal to 1.
Repeating, you want to
Nope. It disappeared. Yes. We no longer use the repeating one. 4.
Would it be less than 4? Or do you have to use
That's to be 4.
That was for middle school teachers to make us much more.
Okay, sine.
Wait, why
Three
did
over
they
5.
teach us something that we don't need?
No, it's fine. It's just that when you get to higher levels of math, they either want you to write it in exact form or they're going to have you round. So for example, in AP Calculus, everything has to be rounded to 3 decimal places or it has to be in exact form. So whether it's repeating or not, it's kind of irrelevant. We don't want to put that line above anymore. It has to do with the types of application problems that we use. All right, sine of s. So now when we look at s, Now we have a different opposite, adjacent, and hypotenuse. 3 now becomes the opposite. Well, the hypotenuse is still the same. It's basically just the opposite and adjacent get switched. So now sine of s is going to be 3 over 5, which is 0.6. Cosine of s is going to be adjacent over hypotenuse, so that's going to be 4 over 5, which is 0.8. And tangent of s, that's going to be opposite over adjacent, so that's 3 over 4, which is 0.75. Now, it makes sense. Does it make sense to you why these are opposites? Right?
Yeah.
The sine of r is the same as cosine of s because we just switched around the adjacent and the opposite sides, no? Okay, so that's one thing I was just saying at the very beginning. We're not going to worry about the sine, cosine, or tangent of a 90-degree angle. You'll learn about that more in algebra 2. But right now, we're just going to look at the acute angle. Okay, now we get out our calculator. Okay. Depending on what type of calculator you have will determine, first of all, how you're going to find a particular mode. So if you have, let me just run through, those of you that have the graphing calculator, what you want to do, there's a mode button here next to this, the blue second. Okay, so click that button. You don't have it. I'm just talking to the people with the graphing calculator. Okay. Chances are, if you're the first owner of this calculator, that the radian mode is highlighted. Okay, so in geometry, we're just going to work in degrees. So you know how like you can measure something in centimeters or measure something in inches, but you're still just measuring? Angles can also be measured in 2 different ways. So one is called radians and the other one is called degrees. We're just going to work with degrees. So you're going to use your arrow button, and then click over so that it's blinking on degrees, and just press enter so that that is highlighted. And then you're going to press second and then mode to quit. That just gets you out of that screen. Now, once you're in degree mode, it will stay there. So you don't have to do this every time you turn your calculator on. If you loan it to somebody that's in a pre-calculus or a calculus class, you'll probably want to switch it back. But, okay, so now those of you with a scientific calculator, you probably already have something that has a D or a DEG at the top. Do you see a D? A DRG? Okay, that works. There should be like something.
My sister destroyed it. I have no
Okay,
idea what
if there is an R, then you need to change the mode to degrees.
Why, Tom? Where is it on your?
Do you see the D?
I see DRG.
DRG, you're fine. You're fine.
So if it comes out to that,
That's fine. I said any of these, you're good to go. If it has an R, then you need to change it.
what do you need to change it? How would you change it?
Do you have a mode button on there?
No.
Then you probably have yeah, this is degrees, this is radian. You want degrees, you're fine. Everybody else is good. You don't have to calculator with you, just make notes. You don't know how to do what? Okay, so you're good. You're fine. Now, this is really easy. We want to find sine of 57 degrees. We're going to hit the sine button. Oh, we're going to type 57. And then we're going to press enter. What? Okay, so what does this mean? Good question.
So challenging. It's the hardest thing in math.
So, again, the 10,000th place is 4 decimal places. Again, when we're working with trig
But
ratios.
why do you want to round up?
Okay, so what does that mean? Now, let me just, you guys can go ahead and plug these other numbers in, but let me explain in terms of what does that mean when we say sine of 57 is 0.8387? Now, remember how we said sine, right, is equal to the opposite over the hypotenuse. So if I ended up with a 0.8387, what that means is if I take any triangle, right triangle that is. So if I take a triangle and I say, okay, I have an angle of 57 degrees, that means the ratio of the opposite side to the hypotenuse is 0.8387 to 1.
Any triangle that has
Any
right
triangle
angles.
that has a 57, so I'm basically saying this is a ratio of approximately 0.8387 to 1. Any triangle with a 57-degree angle, and the right has to be a 90-degree angle, and it has 57. So every triangle is going to have that same ratio. So take cosine of 60 degrees. What did you get for that? 0.5. So think about that. If I have, here's a 60-degree angle. So I'm saying that the adjacent to the hypotenuse is a ratio of 0.5 to 1, or in other words, 1 to 2. Well, what did we just learn about 30, 60, 90 triangles? The hypotenuse is always double the shorter leg. So that makes sense, right? That this would be a ratio of 1.
What would tangent be?
So when you're looking at these numbers, that's really what they're telling you. They're telling you the ratio of one side to another in this particular triangle. So when I see tangent of 30 degrees, it's saying, okay, take a 30, basically a 30, 60, 90 triangle, and look at the opposite compared to the adjacent side. And it will always have a ratio of approximately 0.5774. It's going to turn it into a decimal form. It's not going to give you something with a square root in it. Okay, you need to change yours out of math print and put it into classic, I think it is. You have a thing on, you have a math print on it. This is the mode. 0.9962 for 985. Okay, so now we're going to use these buttons on a calculator and the idea of this SOHCAHTOA to find the missing side length. Now remember, those buttons on your calculator are going to tell you the ratio. So any triangle that's similar to this, that has a 24-degree angle, will have that same ratio of the two sides that we're working with. Okay, so let's look at, okay, so I'm working with my angle. I just have a habit of circling the angle that I'm working with so I don't forget. And then I'm going to label. So we always have two sides that we're working with. In this case, we're trying to find the opposite. And we are given the adjacent. Now the reason I do that is because I don't know anything about the hypotenuse. So I'm not going to use sine or cosine because that involves the hypotenuse. If we use sine, for example, we would have too many unknowns. Okay, so that's why I look at opposite and adjacent. Which one is the opposite and adjacent? That's the last one, that's the tangent. So it's going to be, good, tangent of 24 equals, how about x over 19? Okay, now when we're solving for x, so I'm going to do this all at once. How do I solve for x? I'm going to multiply both sides by 19. Now I want you to be very careful when you type this into your calculator. You can just type in 19 times tangent of 24. You actually don't even have to press the times sign, it'll automatically. You could do 19 tan 24. However, if you put tangent of 24 in first, and then you want to put times 19, that's fine, but you just have to, you see how it puts up parentheses here? You have to close the parentheses. You do. Otherwise, so let me show you. If I do tangent of 24 and I don't close the parentheses, that answer doesn't make any sense.
No.
Because what it's doing is it's taking 24 times 19 and then taking the tangent of that angle. We want to take the tangent of 24. So we can do it this way, we just have to close the parentheses.
Mine is around 19 and down.
I'll look. Yeah. So this is round the final answer to the nearest 10. So that will be 8.5. If you want to do tangent of 24 separate, round this to 4 decimal places and then multiply by 19. So whenever you're actually working with the trig ratio, we go to 4 decimal places, but then in the very end, we'll round this to the 10th place. Because if you round to the 10th place here with tangent of 24, it's not going to give you a very accurate answer. Okay, this is set up for next. Oh, got it. So, look at the angle that we are provided. We have 60 degrees. What two sides are we working with? The adjacent and the hypotenuse.
What did I do?
Now.
Sorry.
So, Alice, before you do it, can you just label X as the adjacent side and 60 is the hypotenuse? Can you just put it in? So it's next to it, it's not opposite. Notice the opposite side, we don't know anything about the opposite side. So when I'm looking at SOHCAHTOA, I'm probably not going to use sine and I'm not going to use tangent because that uses the opposite side, which we're not working with, we don't know what it is. So cosine is the obvious choice. Now, some of you might be thinking, well, could I figure out the opposite side? Could I use sine and figure out the opposite side and then use maybe staggering theorem or something like that? Yeah, you could. But if you're just looking for...
What'd I do?
Okay.
There's more freckles.
Okay, hurry up, hurry up.
Freckles.
No. Hold on, Ellie. We didn't do the 4 decimal places. This isn't going to give us enough accuracy.
Can I write it?
Right. It's just, I would just, okay, it's fine. 0.47, I would go to much. What do we get for X? You might have gotten the same
I
answer.
got 28.2.
Yeah, it might have worked out.
I did it the same way on that one, and I got the same answer.
Okay, sometimes it's not going to be as accurate.
Okay.
So if you're going to do that, do 0.4695. Okay, quickly, because we only have a few more minutes. Okay, use a special right triangle to express each trig ratio as a fraction. Okay, so this is something that we were just talking about, tangent of 30 degrees. So here's what we'll do. We'll just make a quick sketch of a 30, 60, 90 triangle. Now, you can label it just like this with the x's in there, like x, 2x, and x root 3. Or you could just put a 1, a 2, and a root 3. Yeah. So that's what I was saying. You can label it just like this, or you could put the 1, 2, root 3. So if I'm looking at tangent of 30, we're looking at the opposite and the adjacent. Oops. So if I look at that ratio, what's going to happen? I'm going to have x over x root 3. Which the x's cancel. So 1 over root 3 becomes 3 root 3 over 3. Because multiplied by square root of 3 over square root of 3. Or no, I'm sorry, just root 3 over 3.
Yeah.
Is that better? Okay, let's look at sine of 60 degrees. I know. Sine of 60 degrees. So here's 60. Here's 30. Here's my right angle. This time I'll just put 1, 2, and square root of 3. It's the same thing, just without the x's. So what would sine be? Sine is opposite over hypotenuse. So it's square root of 3 over 2. What's your question, Alon? I just drew a picture. Okay, real quickly, inverse trig ratio. So sometimes it's the angle that we're trying to find. So what if we have we know what the ratio is, but we need to figure out the angle measure. So if I know sine of A is 0.4325, how do we solve for the measure of angle A? Second. That's where we use the second. So think about, we have this inverse. It's kind of like, so if we do the sine inverse of the sine, basically these cancel and we just get A. It's kind of like when you multiply by a reciprocal to solve an equation. So A is equal to, so how do we get to that? Well, we're going to use the second button and then the sign. That will give us a sign with a -1. And then 0.4325. And that is the angle. So we're basically saying an angle measure of 25.6 degrees will give us a ratio of 0.4325 when you look at the opposite to the hypotenuse. So it's about 25.6 degrees.